So thank you guys all for coming to the session, and thank you for those of you who are online. This is Michael Lane. He is Northwest Area Manager for Contech, which is a major supplier for culvert and bridges across the state, and I'll let Michael take it away.
Thank you. Will you give me a little warning since we're starting a little late? I might have to go a little quicker.
Yes.
So be like a 10-minute warning.
Sure.
Yeah. So yeah, thank you for having me. I appreciate it. So my name is Michael Lane. I've been with Contech for almost 20 years. Before that, I worked for KPIF Consulting Engineers doing bridge and structure design. Went to University of Washington and have a degree in civil structural engineering. So I like it, not just a material supplier, obviously that's what we do, but really my background is trying to help you guys as engineers understand either our products, other products, how they fit, and try to be honest with, is this the right fit or is it the wrong fit? So with that, I'll probably go pretty quick from a time standpoint. What's really hard for me when I first started with Contech was back at the time, we just did precast arches. Then we got acquired, we do plate structures, we do bridges, and so kind of the ask of covering all this amount of time. And I'll try to be pretty technical on some things, but really, if you guys need more in the future, just let myself know or a couple colleagues that I have, and we're happy to do a deep dive into any, product design or anything that we can help you guys out with. All right. So as I said, we have a couple people here in the Northwest, if you guys hear some of these names, so again, Mike Klein, there's my information. Alex Keenan covers kind of the southwest part of Washington, along with Matthew. Doug covers kind of all of Washington. Some people know Doug Myers, he's worked for a company called Big R, and we'll talk about full Big R bridges. He still works for Contech now. It's a company that Contech acquired. So with that, where I'm going to start is I'm just talk about first, what I call the structure free zone, and kind of how we try to look at some of these processes. We'll go through some of the products, talk about some foundations, and then we'll hit steel, vehicular bridges a little bit. I say pedestrian bridges, but most of kind of the goal is vehicular bridge crossings. But some people will use pedestrian bridges. They're just talking about the horse crossing. Well, why do it for a regular vehicular bridge? Well, maybe it's more pedestrian bridge style. And they're much more cost effective. And then just kind of working with Contech and some of the design tools. I guess before I really get started to the majority of what I'm going to talk about today is not proprietary to Contech. This is just an industry Contech, the way we try to go to market or really help engineers and be out there throughout the country. People like myself helping engineers or owners use different products. There's a couple things that are proprietary to Contech, and I will try to point those out as we go. Okay. And if you have questions, just raise your hand, holler, or if somebody's online and they have something, stop me, I'll have to address it. Okay. All right, so structure free zone. So especially for washed out, I think for the last probably 10 years, we've really struggled in, a lot of people do design kind of design build, or it's a little portion of it, but it's usually around a box culvert, a stream crossing, and it's up to manufacturer, contractor design. And so we really try to help hone that in of what does that structure free zone look like? How deep do we need to go for scour? Where do we need to put the foundations? How wide does it need to be for fiscal? Do we need some clearance for inspection, future maintenance? So the more we can get that defined, then we can start looking at, okay, can we fit a plate structure in there? Or maybe it's precast. In this case, it's an arch. Maybe that's a precast, three-sided structure. Or is maybe a regular conventional concrete or steel girder beam chamfer is the right option? I don't know. And a lot of people ask me, we were talking cost earlier. I don't know until we really start looking at both the material costs of what Contech we may supply or manufacturers, but then also what are the substructure, what are the foundation costs? And really that's the big picture that I try to pull together. I do get a lot of emails from people. Can you provide me a list of these 4 or 5 different costs that I just want to compare material costs? That's not the rest of the story. And that's why I encourage people really look at the whole rest of the story, because just because it's the cheapest material, it's not always the cheapest constructed and also the long term most cost effective solution. Okay. So we do have, I think, Contech a lot of different types of bridge structures, starting with small diameter culverts. We manufacture culverts for Washington up in either Arlington, down in Portland area, or over in Eastern Washington. We have material manufacturing all over the country. I'm really not gonna focus on those. We'll really stick to what we call structural plate. I'll touch on the precast a little bit. And then I'll focus kind of more on the beam span bridges. So I just tried to kind of pick out what I think you guys are gonna probably look at most often. We're gonna look at a lot of huge DOT crossings. I'll show a few just concepts, as we go over. So we'll go back to that clearance box. So plate structures. Who's familiar, if I just say plate, that's real. Everybody familiar? Anybody not familiar with plate? Ah, thank you. Perfect. So, I appreciate the honesty because I think it really helps knowing how fast I go or not. So when we say structural plate, basically what we're talking about is the steel or aluminum plate structure that makes up a shape. Okay, so we have molded plate, which is up on the upper left, aluminum structural plate, bridge core, and aluminum box cores. Kind of all a couple different products. So what are all those and how do we really decide what to use? So probably the first thing that I hear a lot from a county or the city or a lot of the engineers, I can't do a steel structure, it doesn't last long enough. Okay, we're tearing out this old culvert that's, corroded in the bottom. And I don't disagree, but a lot of those structures were probably installed 50 years ago and met the design intent at that time. Okay. And so one thing really to consider is, back in the day, we typically would just install that culvert right in the bottom of the screen, we wouldn't countersink it or do anything. And then we have abrasion that's going through the invert. Once you lose the galvanizing on a steel structure, yes, it's going to corrode. And especially when it's a very, very thin gauge type of material. I don't see that to be the problem anymore, because really what we're going to do is typically bury those structures. But here's a great chart. This came out of Caltrans, and basically what they did was they inspected thousands and thousands of those galvanized steel culverts, smaller diameters. And what they did was they put together this chart. Basically, you have resistivity on the bottom, and then on this, on this axis, then you have the pH. So if you go through that, and we get 20, let's just assume 28 years for this one. But that is for a thin gauge type of material. And then so what we do is we use this chart here to factor it up, because the lowest gauge that we made is a 12 gauge structure for structural plate. Okay. And in this case here, you can say, okay, instead of going 12, I'll go 10 or 8, and then you can increase that service length. Okay. So I think what my big takeaway to engineers is, let's understand our site. And let's understand the materials and design it appropriately. And I think that's what we can really show for a lot of the sites within Washington. If we don't have hot soils, we can show a galvanized structure will last 75 years. Typically 75 years is what WashDOT, any of the state agencies, we need to design to as engineers. Okay. Does that make sense? Okay. The other option is we could go to aluminum structure. And aluminum structures just have a broader pH resistivity range from a durability standpoint. And so this chart here shows, kind of what we were just looking at, but in more, what are those thicknesses? So you kind of see how this goes thicker and thicker and thicker. So we can really get some material that is very thick, from a durability standpoint. So I'm gonna start passing this around. So this is what we call bridge core. And so this is galvanized steel. What a lot of people used to be familiar with was multiplate, which has been around for about 100 years. And that is the 6x2 corrugation here, both of them galvanized steel. And then the bridge core is 15 by 5.5. It's really the difference of those two. I kind of related to, if we're going to build a deck at your house, and that deck we need to span 4 feet. Well, we might be able to use a 2x4 to span that distance, but now if we need a deck that's going to span 10 feet, we're going to use a 2x8 or a 2x10. It's just a much deeper material, so we can span much further. Okay. So I think that's probably the biggest takeaway that I've had over the last 10 years is really that bridge core has really opened the opportunities to different shapes, much larger spans, deeper fills as we do more and more of these string processes. Okay, the other option is would be going to aluminum structural plate, and that's a 2.5 corrugation. And so what's really cool about aluminum structural plate, very lightweight. So these are aluminum bolts, and then there's steel bolt. Now, typically, we don't supply aluminum bolts with aluminum plate. It's not that we can't, it's just for ASHTO, it's not a requirement. So if you have a project that it is, I would make sure to really make sure it's very clear in the specifications. These are ribs that are packed around here, so the ribs go on aluminum structural plate or box culverts. And that basically stiffens up the structure. And, so we can either have longer spans, higher fill heights, or meet the requirements at next time. Okay. This is sort of looking, we have a ton of different shapes, I shouldn't say we, but the industry. And so, well, a lot of people are familiar with this, put out what's called structural plate design guide. And in the front of it, this basically summarizes the tables in ASHTO. So that engineers like us, we can go in there and go, okay, what's my span, what's my rise? Is there a structure that and meet the requirements of a road? Okay. So if you guys don't have one of these, let me know. I have a couple copies, but I can also email the PDF of them. And so why do we have all these different shapes out in the industry? Anybody? Clearance box. Look back to that clearance box, and either it's a clearance box or it be a wide span, but I don't have a whole lot of fill height, so I'm gonna go to a culvert shape. Or maybe I have a lot of fill height, and if I need to go to a single radius arch because I need to be able to carry that load, I couldn't carry that on this really flat structure with a lot of cover, okay? This one here, this one actually fits in ARIMA, so ARIMA is for railroad, so we can drive a train through this one, so that's kind of where my thing is there. For structure free zone, it's a lot of what we kind of do in the industry, and that's kind of the first thing I just look at when people ask me. I go, well, do we have a distance from your stream to the road, and how wide is it, and how deep do I need to make that? Okay, and then we start looking at different shapes. Okay, so why do we a lot of times do any types of different structural plates? A lot of times it's lightweight, you can construct. Majority of the time, we don't need a crane out on a job site, it can be done with lightweight equipment. You know, if it's aluminum structural plate, I can actually pick up some of our smaller aluminum structural plates. So, you know, if I can do it, you know, most of the contractors out there, they can easily pick them. Some of the end treatments that we see, so these are one of the bigger things that I started seeing on your guys' projects is what's happening at the end of the structure and what's most cost effective for that site and simplest for some of the contractors. Are we doing a structure that's up in the woods? Or, you know, is this down in the city? And those are the different things that we need to think about. So we can do up here, this one's for Mason County, this is aluminum structural plate, head wall, wing walls. We can also do those out of steel. On the right, we just be a beveled end section with a cast in place concrete collar. Definitely, I usually encourage, we try to stay away from cast in place if we can. What I would rather just see is almost that structure extended out. From our perspective, it doesn't matter, but I think from the contractors and the questions I get of trying to cast concrete up and around structures, if we can just either, what I would say, square in that structure is more cost effective. Okay. But there's safety reasons and other reasons why you might want to do a slope collar or bring in more line. The other option, you know, going to, you know, some type of wire-based wall or just doing a precast keystone block wall or something like that to keep that structure short. All right, so I'll just kind of flip through these pretty quick to show kind of the different structural shapes, this different designs that were done. So again, this one's a 26-foot round structure that we did for Washington. What's unique about that one versus say a precast, more cost effective, but also it handles, this is almost 50 feet of cover. So that's what we're seeing a lot of these projects. 10 years ago, we've done all these easy ones. Now we're getting into these harder and harder, more costly, you know, crossings. And we really got to look at what are we doing, how are we doing, and it does cost more. I also really like the pipe work. Great shape. You know, from we're not excavating too far, but still backfilling that structure. You know, where we're, you know, that fish rock on the inside of there. The other one that I see more often, I know these are, you know, just regular pedestrian crossings. These could be animal crossings. But when we go to this underpass shape, what I really like is the ability to get equipment in there and be able to build that straight. And so I really try to encourage you guys as engineers, from what I've seen with contractors, the more room that they can have, yes, structure might cost a little bit more, but if they can get hydraulic equipment in there, it's way easier to build that stream. And then ultimately, who's gonna be maintaining the stream in 20 years? If something gets caught in there, can you get that woody debris and does it pass through there or not? If you need to do some maintenance, having that equipment there. Okay. Regular just box culverts, so we can do these out of aluminum, or steel. Obviously, if we're struggling from the distance from the stream to the road, box culvert fits great to try to get that long span. But typically with, like, especially the aluminum box culverts, they can only handle 5 foot of fill to meet ASHTO. We can design it for more fill, but ASHTO's requirement is 5 foot or no more than 5 foot. But we can also go to the galvanized steel bridge core, and then we can handle more and more cover. But that's kind of where I go. If we have more cover, let's change to a more structurally efficient shape. Okay. Single radius arches. This is a multi-radius. So you were asking me earlier, can we do different radius type arches? We definitely can. We'll do a single radius, which is kind of either the two on the right, or multi-radius. So that just means, here's one radius and there's another radius. We can do 3 radiuses if we need to. So I'll show you a couple different shapes. So like this is one for washdown. So the other thing that I also look at is, just because it's not in this book doesn't mean we can't do it. So like, for example, this structure that we're looking at right here does not show up in this book. The biggest span is a 23-foot span in here. This one's a 28-foot span. And so that's kind of where just contacting us. If you said, can we do a 60-foot span? And maybe that's getting outside of the realm. But this is kind of where we have that clearance box and know the project requirements. We can kind of go, here's the different options that might be. Okay. So this is kind of the end structure there. But then if we take that, this next year, we're going to do a 42-foot span. So I kind of go, in Contech, I almost double the span of what's in this book. But we're engaging, us as engineers, you guys as engineers, and we're modeling it and making sure it works structurally. And then it's cost effective. The one there on the right, originally for washout, that's a precast structure. Contractor, this is way out on the peninsula. Let's try to save some money, try and get the cranes out there, cast in place concrete, everything gets covered up wherever we get from the cities. Okay. And we've done a couple of plate structures with them, and so that's where they really said, hey, can we make an aluminum structural plate work? We think it's far more cost effective. Okay. The other thing that's great about some of the structural plate is being able to do elbows. So this is one job out by Forks, but being able to follow that straight, and so we already have an existing culvert, maybe there's an elbow in it. Instead of straightening this out, making it much wider, more cost effective, really follow that stream. Obviously when you see your rock, it makes it harder and harder to, excavate through that rock. And this again was my picture too that I talked about earlier. We get that hydraulic equipment in. Let's try to make it, even if your structure free zone is only 3 feet tall, if you can, you have that room, let's make that structure much bigger so you can get equipment in there. All right, so we'll kind of switch gears and we'll talk quickly about precast, just a couple different options. So within what Contech does for precast, here's pretty much our spans going from 12 foot, all the way to realistically 84 feet. So kind of just like structural plate, you can see all these different shapes and different colors, different clearance boxes or different kinds of cover. That's why we have all these different shapes to try to fit, these different sites that you guys make us see. Okay. What's nice, kind of just like on the aluminum structural plate or plate, we can do head walls, wing walls, and this just kind of shows precast arch with large precast wing walls, large head walls that are attached to the structure. Sometimes, we're looking at these pre-manufactured solutions because you guys are trying to design something that's going to be built in a week, 2 weeks. We're not sitting out there trying to cast concrete. If you go down to California or other areas where you have all this time, we don't have the fish window. So we're trying to do what's the speed of construction, build these as quick as you can. Here's just a 60-foot example with HDR Fish Pro on. So just, fits the environment, looks nice. If you guys are from the west side, you guys go under, the Animal Crossing, so that's one that I get involved with. That's kind of where we look, we do all the little small structures, but then also, also get involved with washtowns, do some of these much bigger, precast structures or flood structures. Here's one that I did a couple years ago. I just want to show this, like a question a lot. Can we do pile foundations? Yes, we can put these structures on pile foundations, but to me, it's kind of a red flag. Let's make sure we're designing the structure appropriately. Geotech, we're doing these big buried structures. It might not be the right solution. Maybe we should go into a girder bridge if we're burying the structure. Just because of the dead load of the earth around it might not always be the most cost effective. So let's really think about that first. But that was a great project. I mean, opened up a huge excavated area. It was very successful from that standpoint. Just making sure we understand the cost a little bit. So design specifications, I'll go through this real quick, but all these structures we're designing to ASHTO, be it a precast structure, plate structure. It's this soil structure interaction. So also something to kind of really think about too. When this goes out to bid and is in construction, we contact and we want to make sure that contractor is building these correctly and the backfill is being done. That's probably the biggest thing that when we start seeing problems is the backfill wasn't done appropriately. Either the contractor didn't have the right material or it wasn't specified correctly. And especially as we get longer and longer spans, we want to make sure that material is supporting these arches. Okay. We use a program called Candy, and that stands for Culvert Analysis and Design, FHWA program. It's not a proprietary. You guys can download it. I have a couple structural engineers here in the Northwest, that we try to help them understand the program because more and more bridge engineers, I was one at the time, wasn't very familiar in doing any buried structures. So how do we start designing it? And so more and more people are kind of learning or trying to understand how to do that. So if you have anybody, we're more than happy to kind of give a quick hour, 2 hour of your Candy. Here's how it works. Here's how we use it. Okay. So basically what Candy is, if you're not a structural engineer, you're gone through, or I should ask anybody know finite element. Okay. So what finite element basically is, as an engineer, we take all these little tiny different nodes and we can assign them different material properties. So obviously the ones in color are assigned the same material properties. Then we can put a load on the top and each of those little pieces will distribute that load throughout the soil or throughout the structure. And so for ASHTO, this is what we need to do when we start getting these longer span structures. So some people ask me, well, why, when we go to these bigger structures, why does it take more time? Because we're having to do this analysis, in the background. It's no longer just pull it out of a catalog. So, I guess any questions on that? I know it's quick, but the other one would be seismic, automated address seismic for buried structures. So we use that program and we basically take the structure and call racket. So we push it over to the earthquake, check all the loads in it, make sure that it can stay there, and that's how we check it. So, if anybody wants more on that one or online, just let me know. I got plenty more slides on happy to talk on that.
That's hard, sir. You guys provide the scouts and the contract materials.
We do, yeah. Yeah, just make sure we know about it. There's some things geotechnically that some of the geotechnical or geotechs are not giving the information like in soil report. So they need to know that that is expected, so that they provide that. But yeah, that is different. So speaking of geotech, probably something I really want to hit is, I hear a lot of small projects. We don't want to spend money on geotech, okay? We'll just let the contractor do it, okay? I personally, and we typically don't supply foundations. Sometimes we will, but usually we're getting asked to do the design. We will not do a design on a structure without a geotech report or the owner telling us what to use, okay? So gets back to liability. We're all engineers. We're gonna sign and stamp something. We need the information to be able to do the appropriate design, okay? So within Contech, we really try to encourage landowners, whoever the owner is, to get geotechnical information. I personally don't think it's cost effective to do it later. Because if you're a contractor, am I gonna build a footing this big or is it this big? And that matters. And usually the cost of the foundation is more costly than doing the geotech report. So if we don't have that information, most people are gonna assume conservative numbers, which as an engineer, conservative usually means bigger and more costly. So that's my quick 2 cents on foundation design. So the other thing that I encourage, this is a washed out job, I'll show later, but was a design build, and they provided geotechnical information, the green and the green. Being a design build, it's usually the most cost effective structure that meets the design intent. Two of the contractors did a buried structure, so right here, but we had no geotechnical information. We had to assume that at bid time, okay? And so it makes it really tough that, you know, we're being too conservative or not conservative enough. So the more information we can get, the better, okay? So from a foundation standpoint, we do have what's called express foundation, so this is one of the products, I think this is probably the only one I'll talk about that is proprietary from Contech. I'll go through it and, you know, if this is something you guys want to use or give an option to an engineer or to a contractor, we talk about ways you can write a spec and leave it up to the contractor to decide which one's most cost effective. So really what express foundations are, that previous one was precast, this one was plate, basically a precast or a plate form with all the rebar already installed in it, except for wherever we would have longitudinal splice. So this one's gonna butt up to the next one, we're gonna have some tie rebar across it. I like this from a foundation standpoint, instead of doing solid precast, because we have continuity in the foundations, okay? If we ever have settling, seismic, scour, we have a continuous foundation versus just button it up. There's a couple of them going in, like Mason County, we're doing 2 for Mason County this year. I think from their standpoint, the county likes it because their crews go out and install this and you're just filling with concrete. You don't have to, you know, be really savvy. You don't have the whole cost of the forward. So just an option out there if you guys do want to look at that for some of your projects. Okay, so scour. We kind of talked about structure free zone, and this is probably a big one that I'm seeing, especially with a lot of these washed out projects. Is scour on some sites not 2 feet. We're seeing sites 4 feet, 6 feet, 8, 10 feet of scour, and so really knowing that at that 30% design phase for being aware that that really can affect your structure what you choose. Because I see a lot of times we'll get into these projects at that 30%. And we're kind of doing this huge design and we're spending a lot of time really refining costs. But until we really know that, those costs will change and the structure overall will change a lot. So just something to think about or make sure we're assuming something that's maybe conservative to start with. Couple different products that we do support. I'm not going to talk a whole lot about these, but Armor Flex is one of them. The nice thing about Armor Flex, you know, it's an engineered product for embankments, put them underneath structure, it can't be vegetated, push fish rock on top of it. But it's a design material, so we know what shear stress that material can take before failure. Okay. The other option, this is a job for Lewis County, would be it's called Ajax. So this is just armoring a bridge abutment. They were having problems with scouring underneath the bridge, and every year dumping a bunch of rock every year. Some of these products we can get to stand steeper than your typical armor, so that we can open up that channel, decrease the flow a little bit. You know, so it kind of helps twofold there. Okay. So now I'm going to kind of switch gears. How are we doing on time? Time do we have, if you don't mind?
14 more minutes.
14 more minutes. Okay. And we're going to hit our regular, you know, why are we designing a steel beam span? Structures. We're going to kind of be below this line here and looking at why steel bridge, you know, kind of very similar to plate, lightweight, cost effective is why, you know, we're looking at some of these. I put this together, it's kind of cool with 8 steps to choosing a particular bridge. So I'll go through these really quick, you know, if you guys want this presentation later. But it's really, what are the outside influences? Who's influencing? Is it private funding, public funding? You know, what is that funding source? Are there any architectural requirements? You know, what's the site layout, permit requirements? Or does the structure only need to last 10 years? Or are we designing something for 75 years? What about foundations? What are we doing from the foundation standpoint? And what are the different site constraints? Where's it being built? Kind of thinking about that. What's the geometry requirements? So we put the bridge on a slope, going in, the direction of traffic, or is there a cross slope on them? Kind of thinking through that, what are the requirements? The width of the bridge, which I see for a lot of these, beam span style bridges, usually here in the Northwest, we'll build them in modules, okay? Most very cost effective, but understanding is this, a 14-foot road for private residents, or is it a 16-foot, maybe it's a logging road, or is it 24 feet because we need a 2-lane county road, so understanding those requirements. Do we have a skew at the end of the bridge? Or maybe it's a horizontal curve that, especially for some of these, we're trying to put a bridge here, it's a horizontal curve, so maybe the bridge needs to be a little wider, so we continue that curve, on the bridge. So what about what types of steel should we use? Or excuse me, what types of bridge? I kind of mentioned this earlier, do we look at a pedestrian bridge? And, some people kind of go, why would we do a pedestrian bridge for vehicular access? One, sometimes it's gonna be more cost effective, a different style. Some people, if you're doing this for a private, residence, maybe they would rather see a pedestrian bridge going into their property. When I say pedestrian though, it's still designed for vehicular loads. It's just, that's not the main load. And when we look at AASHTO and we design a bridge and we say it's a bridge, that's a bridge that's like on I-5, well, we got a continuous truck traffic, and that's how we're designing it. If we go to a different code within AASHTO, we can design it for pedestrians with occasional or overload, but a regular, like a semi-truck. So just something to kind of think about from a cost effective as you're working with people. Further, we'll get into kind of now steadfast truss and beam span bridges. This is what I think a lot of people, which you guys are familiar with here for the Northwest of, we say a big arm bridge. Cost effective spans up to about 120 feet. Ships out modular components, kind of like I mentioned earlier, typically we'll try to, what we see most of the time is gonna be your 14 or 16 foot wide, type of bridges. Typical increments, 40, 60, 80 feet, you can make different ones in between there. But this is, if you guys haven't seen them, this is why a lot of people do these is, you almost, next slide or slides, be like a bridge in a day where you're getting these bridge components that come out, pick them up with an excavator, a log handler. Some people use a small crane and just set them in place, so. There when we start kind of looking at this, where you go, okay, we're gonna, set the abutments, set the back wall, set your bridge in place, and put your gravel on it. You're really getting a bridge in a day, maybe 2 days, depending on how long it takes you to put in the foundations. So what about steel finishes? This is the other thing that I consider a lot of people do. The one up top right, weathering steel. We still need to make sure it's in the right environment. If we're down on the coast, if we're in a really rainy environment, making sure that there's air movement and other things. Otherwise, you are going to get, a little bit more weathering than what you might expect. There's other things that we can do. We can blast those bridges, or we'll sandblast them, and that'll actually help take off the mill scale and will help them last a little longer. So different things that work with us on. Or the other option, just going to galvanized bridge or painted bridge is the other two. All right, we need to design for custom loads. Is there something special out there for the site? U80 loading is pretty typical for us in the Northwest. It's your regular yarder that typically will be get logging. So that does go across the bridge and you need to know about it. Please make sure that's in the specifications. Sometimes with these larger loads, though, specify them as an overload. So we're not designing them to the regular AASHTO parameters, and that'll save some money for you. Okay. Railing requirements, I'll go through this pretty quick, but there's either crash tested or non-crash tested. Most of the time we are doing non-crash tested rail, meaning we're designing for the load on the bridge, but it has not been tested for AASHTO. Okay. And I would say most of the bridge, or a lot of the bridges you see out there are that, non-rated. So here's a couple of the different deck types that we can use, gravel to asphalt. A lot of times we'll see this one where it'll just be the steel deck pans, and they put a running surface down, very cost effective. Or maybe it's a county road and they want to do a cast in place deck, as you see on the lower right. All different deck types that we can design around, or even, for cast on roof that you can do. Almost done here, so bearing surfaces. I kind of doubt you guys will ever see isolated bearings, but typically it's just a thin bearing, elastomeric bearing pad. But we can also design and specify an elastomeric bearing pad as well. Okay, I know that was pretty quick. Any quick questions on the beam span? Kind of design options, any of that? Okay. All right, so there's a quick summary of those 8 steps, and I'll give this to you guys if anybody wants them. Look at a couple different pictures. This is, one that was done down in Thurston County. This is simple beam span, 24-foot wide roadway, 2 lanes. This is another unique one. This is one down in Thurston County, but being a lot of these beam spans, this is just a regular rails to trail project. But the way it's designed, that contractor was actually able to use his asphalt truck, drive across that. So we're designing it for ASHTO. The design code is pedestrian design code, but again, you can have it as an overload so that you can't have emergency access, or truck traffic on top of it. What I like about this one too is they incorporated this little lookout, so it's a regular jogging trail, not bicycles, but then this little lookout, so you kind of watch fish spawn, birds, or whatever. So just kind of these little unique things that you can do to your projects that don't add a lot of cost, but really make it a little more unique. And actually I'm standing on that bridge right now, and so this is actually the regular, vehicular beam span bridge right next to it. All right, so how are we doing on time? We're talking about
6 more minutes,
is that until 9 o'clock?
9:50, or I'm sorry, 8:50.
Awesome. Okay.
Yeah,
so
you're doing fine.
with Q&A, all right. So foundations, so very similar to plate structures. Let's think about these foundations, what options are out there. What things to consider. Can we do deep foundations? Absolutely, you can do deep foundations, kind of the upper right. So like for beam spans, a lot of times then we'll see a steel pile cap put on top of them, or it could be a precast pile cap, or it could be cast in place, and then set the girders right on top of that. One thing nice about doing the steel pile cap, this mesh here, there's a lot. It's nice that there's some adjustability. You can kind of put those beams and things are off a couple inches here or there, and then we just weld the setting plates on top of those where that was precast. Then it makes it a little bit tighter. You don't have to move around much. But I think this is a good slide for kind of thinking through. Well, do you do a short bridge or do you do a long bridge? Well, what are the site requirements? Those foundations are the big part. Like in that upper right, do a little short bridge. Is that more cost effective versus doing those huge walls and everything else? I don't know. So we gotta kind of do that quick cost analysis of type size. On that one, it seems like like making that bridge twice as long would have been a little more cost effective, and tapering up those slopes. But maybe there was some site constraints or something else that people were concerned about. So just kind of thinking through that and what are the right options. These are some of the abutment options that we definitely look at. Would be, I'll go back to this one, that on the right, it's like people know a pill figure, wire face wall, or this is what we call bin wall. One nice thing about bin wall is some of these remote sites, contractors can pre-assemble these big bins, put them on the back of their trailers, take them out to the job site, and set it in place, or pre-assemble here on the job site and then let them in place. Like you take this site here, this guy's was standing in water, so they're setting those bins in, prepare the subgrade as much as you can, set those bins in, and then those bins you fill up with gravel. If that was a cap in place abutment, it's quite a different process, to really do that right. So just kind of showing you some examples of different things that could be done. So working with Contech, how can we help you guys, look through these different options? And it gets back to your talking earlier, what's the cost? If I get a cost, and how do I figure that out? I found this design tool really helpful for engineers. It doesn't have all of our structures in there. We're slowly adding them as we get design developed. But like this one, it's great, you can kind of put in what width, what length of the bridge, and even if it doesn't have the option, you can at least go through it and then let us know. Hey, it doesn't have the width of the bridge I need, but here's the concept, let me get it going. So, you know, as when I was doing consulting, it's nice if you're doing the type, size, and location report. Maybe you got 4 or 8 pages describing your site and what options, and then in the back, here's your appendix with some drawings and concepts. But it takes you 5 minutes to generate this, and that's where I try to look at for you guys, how do you do things faster and faster? Or, you know, less timely for you. So once you enter that information within probably about 5 or 10 minutes, you'll get an email that'll, you know, kind of show you the plan, view, cross sections. So in that here option here, you know, here's your plan view, your cross sections. Loading for your abutment, so you can do preliminary abutment design. So these are some of the tools that we're trying to help, you know, speed things up for engineers that are designing around these structures. We do those for our varied structures. Our varied structures are not going to give you reactions. You know, there's a lot more that go into them. 2-foot of cover or 20-foot of cover. We don't have that automation yet. But what's cool is, you know, you put in your different clearance boxes, you know, so it's an animal crossing. You know, all different things, could be a plate structure. And also there's an option in there where you can pull in a photo or Google Earth, you know, map and kind of put that structure in. So it's great, maybe if you're meeting with a land. Okay, here's kind of the concept. Here's a photo of your site or a drone shot. You know, maybe you have some plans and you're dropping it in there. Obviously, this one looks a little different because structure will be under the road, but you know, doing the best we can with some automation and making it look somewhat realistic. We can then help you guys, you know, generate actual drawings. We can sign and stamp drawings for you, pre-bid. So we need to discuss if we're going to do that. You know, we're going to design and what we'll live for our own structures, or we can do it at just the first bid. So different options out there. Just get a hold of us. And we can kind of look through different things. Budget cost estimate. So happy to help you guys out with these of looking at, you know, in this case here, there's precast arch cost, walls, wing wall cost, you know, maybe a little bit about time. A lot of people ask that, what's the time on these structures? How long to design, how long to fabricate? So we have some time, we'll talk about that a little bit more. The other one that we started generating is installation costs. And currently, we only are doing this for our precast for plate buried structures. But again, it goes to, you know, if this is the material cost of that previous example, what's our foundation cost? What's the install or labor? What's excavation, backfill? You know, here's just a kind of a list of materials to start thinking about. It's not just your material cost, but the overall cost, you know, and, you know, be it drill shafts or piles or shoring, you know, a lot of things that we're not involved with, but at least it kind of helps you guys think about it and what it costs. You know, we don't always have, you know, exact cost per square yards of material, but just help us. If you go, hey, for my site, it's $45, we'll plug that in for you. Okay, so that's something we can help with. I mentioned this, but no PDAH credits, if anybody needs them. Okay. So if you guys have any questions, I know that was really quick. Contact information here, so we can open up for questions. We have
It's 8:50 exactly, so I think
8:50,
we got
all right.
2 minutes for questions if anybody has them.
okay. And I can go back to slides too, if it helps.
I've got one question.
Okay.
Back on the geotech stuff, that little map you showed the ideally four geotech points at the corner of
Yep.
at the four corners of the bridge. I've got a site where I can really only get a drill rig to one spot within that set of 4. What's your comfort level with something like that?
So I guess our comfort level is, what's the comfort level of the geotechnical engineer that's going on site?
Yeah,
They're gonna do the borings and drillings. And so if they know the site, and they go, okay, this side's very representative of this other side. That's up to them. I think the way we look at it is, we're not geotechs, so we're relying on somebody else's expertise. So if we think one side's rock and the other side the bog, we can only get access to the rock side.
Right.
Are we in trouble?
Yeah, I'll add that, Matthew and Alex sent me a really nice two-pager, that helped me hire the geotech consultant. Just letting, just a line out of what's needed. And
Yeah.
all the detailed information from the geotech report that you want to make sure you spec in the RFQ for.
Okay.
The consultants.
I mean, I would say in general,
Yeah.
one mooring's probably fine for the majority of our projects. It's when we get to longer and longer spans, especially, like I showed some of the DOT projects where I will say there's a lot more that we go through sometimes on the DOT or DOT and scrutiny. It is, we're gonna rely on that geotech to give us all the recommendations from the site and tell us what to use. Well, any other questions?
Not an engineer at all, so
Okay.
it's awfully new to me, but what's the typical design lifespan of some of these structures that you talked about getting up to 75 years for the steel plate? Or is it similar for the aluminum plate or some of the other, like the beam span bridges or anything like? I guess like we're working with landowners and project managers and they would know.
Plus lifespan,
Yeah, like is it, you can make any of those structures get to,
you can make any of those structures work.
okay.
It would be like, say, if you got a landowner and you did, I showed weathering steel bridge. And let's say they're right in the Puget Sound, and we have salt water that's coming up in there, and you got salt spray. Well, that one might only last 50 years, It's probably not gonna fall down, but people are gonna go, man, this bridge is rusting a lot more than it should be. And that's gonna go, well, we put the wrong material in, or the wrong expectation, but some people will go, we don't care.
Yeah.
A lot of the timber companies, they don't design for seismic, they don't design for things, and they go, we're gonna use that bridge this year to log this huge area. We may not be back for another 40 or 50 years, so why do we wanna go spend an extra, say, 200,000? If we do have a seismic event, they go, what's gonna happen? My bridge is gonna slide off the beam, and we'll go out there again, we'll pick it up, and we're gonna probably have a lot more problems with the whole road. So I think that's a great question, really understanding what are the design requirements, and let's not design to a DOT standard, when we're really okay here. It's gonna perform like just fine.
But you can still get up to 30, 40
Yeah.
years in these if you.
Yeah, there's different things we can do, we can be pretty much any lifespan you need. Or 7,500 is what we'll stand by.
So you said you come in at like 30%, what's the appropriate time to start with design?
I have people that send me a photo of the site, and be like, we walk it and it's 10 feet wide, and typically, my biggest struggle when I get that, and it's usually a homeowner. Is it really that, or an engineer, do you understand what you're measuring? Because usually they'll go, yeah, I can jump over the stream, and I go, is it a fish bearing stream? Oh, no, it's just a ditch, and I go, all right, sure. And I go, okay, it's probably gonna be 20 feet wide, it's not just gonna be 6 or so. But yeah, more than happy, even if, probably the biggest is what's the span, and then what's the distance from the stream to your road, so we kind of see what's that, what can we fit in that structure